Biorefinery System Module 1, Segment 4, Lignocellulose Biorefinery Engineering, with me Yusuf from Institut Teknologi Bandung. Early utilization of lignocellulose, mainly burning biomass for heating and cooking. Traditional use of lignocellulose was inefficient and uneconomical, but it is still one of the most widely used energy forms in the world. Since the 1990s, more and more countries have developed specific policies of lignocellulose energy industry development. The lignocellulose industry has gradually become a strategic emerging industry. In the petrochemical industry, each component of the complex substrates is converted into different products by fractional distillation and catalytic conversion technologies. Even residue can also be converted into an appropriate product. This is called as refining. As with fossil oil materials, lignocellulosic raw materials also have complex components. The refining concept is introduced into the development of lignocellulose resources, forming the new biorefining concept. Lignocellulose should be used as a feedstock for multiple products. Each of the major components of the raw material is converted into different products, achieving full utilization of the raw materials and creating the maximum value of the products. Comprehensive utilization of each component involves the design of production technology and integrated refining processes based on the diverse characteristics of the lignocellulose components. Therefore, all plant components are converted to a corresponding product with no waste emissions, forming an ecological industry chain. Biorefinery refers to a production system where a wide range of processes are coupled for the production of bio-based products from different biomass feedstocks. There are 4 key points in a biorefinery concept. First, optimize the use of resources. Second, minimize waste production. Third, maximize benefit and profitability. And the ultimate goal is sustainable development. There are several key points of lignocellulose biorefinery engineering. First, feedstock engineering. The composition of lignocellulose is very complex, which makes conversion of components into a useful molecule is difficult. The purpose of refining lignocellulosic feedstock is to improve the homogeneity of the raw material tissue structure based on material components and structural properties. Further elaboration will be discussed in detail in Module 3 and 4. Second, conversion engineering. Most of lignocellulose is from plants, hence it has the properties of plants such as cells and tissues with different functions. Thus, lignocellulose has multiple functions. According to the demands of the end products, the appropriate component or structure can be selected by using appropriate technologies for conversion. Further elaboration will be discussed in detail in Module 5 and 6. Third, product engineering. Product engineering develops products to meet the end-use performance requirements. Lignocellulose product engineering is the design, processing, and production of lignocellulose products based on the end-use requirements, making abundant use of lignocellulose resources. Further elaboration will be discussed in detail in Module 9 and 10. Fourth, process engineering. Biorefinery processing of raw lignocellulose is mainly composed of 3-phase systems: porous medium, gas, and liquid. Lignocellulose biorefinery processing can be investigated as a porous media transfer process involving heat and mass transfer, percolation theory, capillary diffusion theory, fluid mechanics, and thermodynamics theory. Further elaboration will be discussed in detail in Module 11 and 12. For a better visualization about biorefinery, you may want to check these videos in YouTube. Until the next module, I am Yusuf from Institut Teknologi Bandung.